Okay, geometry students, in this video we will be learning our other two ways to prove that triangles are similar. Okay, remember we have already learned the angle postulate way of proving that two triangles are similar, and now we're going to learn two other ways today. Okay, your heading today is this, so please copy your heading down. Proving similar triangles by side, 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 and side angle side. The lesson number is 8.5, and be sure and include today's date. Okay, lesson number is 8.5, and be sure and include today's date. Once again, proving similar triangles by side, 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 and side angle side. Okay, alright, here we go. Copy this down, and let's get started. Now, first of all, let's jump right into this, okay? No need to waste any time. We are going to start off by looking at a theorem right away. There are two theorems we'll be looking at today. Here it is, the first one. Please copy this in your notes. Theorem 8.2. Theorem 8.2. It is called the side, side, side similarity theorem, and it states if corresponding sides of two triangles are proportional, then the two triangles are similar. Okay, I'm going to pause a second while you copy that down. If corresponding sides of two triangles are proportional, then the two triangles are similar. Okay, please copy that down. If corresponding sides of two triangles are proportional, then the two triangles are similar. Okay, now, here we go. I'm going to draw a triangle like this, and a triangle like this. I'd like you to do the same thing in your notes, please. Copy this down. We're going to call this A, B, C, D, E, F, okay? Now, now watch this. Take good notes on this. AB over DE equals BC over EF equals AC over DF, okay? So if this side here over this side here equals this side here over this side here equals this side here over this side here, then we can state triangle A, B, C is similar to triangle D, E, F. Okay? So that's what this theorem is saying. Listen, you might not know one angle in either one of these two triangles, but it doesn't matter. If you know all three sides of this triangle, and all three sides of this triangle, and they're all proportional to each other, then you have similar triangles for sure, okay? And that is what theorem 8.2 is saying. Alright, not too difficult. Alright, let's continue on. Now, let's move on to our next and last theorem for the day. So please copy this down. Theorem 8.3, the side angle side theorem. Now listen very carefully, students. This can be confusing, so really be careful. Copy this down. If one angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Now it sounds a little confusing, but I'm going to break this down for you in a couple minutes, okay? So copy this down. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar, okay? Give you a couple more seconds to copy that down, then we're going to talk about it. If an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides, including these angles, are proportional, then the two triangles are similar. Okay, now watch what I'm going to do here. Please take some really good notes. I'm going to draw a triangle over here, and a bigger triangle over here. take some really good notes on this. Watch carefully. Okay, if, and I'm going to pick an angle, it doesn't matter which one, if angle A is congruent to angle D, and, now watch, AB over DE equals AC over DF. And I'm going to come back to this in a second and explain this, okay? Then triangle ABC is similar to triangle DEF. Now, listen to me carefully, students. Do you see what I did? We have an angle here congruent to an angle here. Now, if that's the case, you cannot use this side here and this side here. That's angle side side or side side angle, okay? It has to be this side here with this side here and this side here corresponding to this side here, okay? That's why I said AB over DE equals AC over DF, okay? So whenever you have this scenario, please listen to me, students, whenever you have this scenario here where you have an angle congruent to an angle and then these two including sides are proportional to these two including sides, then you know right away these two triangles are similar. Now, I really wanted to prove this theorem back here, but I just chose not to at this point in time. I wanted to get you guys more into the homework and also work out some problems. This one here is proven if you want to look at it in your homework. Now, you're not going to do it because it's about a 15-step proof, and we're just not going to do that, but I think you'll find this. Excuse me for yawning, I apologize. I think you will find this in number 21 in the homework, but you're not going to do it again. But if you want to see a proof of this, that's where you'll find it, okay? So, whenever you have an angle that's congruent to another angle of another triangle, and then these including sides here and here and here and here are proportional, then these two triangles are similar no matter what, okay? Alright, now, let's continue on. Let's apply these two theorems to some problems. Once in a while we do this, okay? So we're going to turn your books today to page 403. Please turn over there and let's take a look at numbers 1 through 6, okay? So I'm going to keep talking while you're turning over there, page 403, and let's take a look at numbers 1 through 6, okay? And remember, as always, you are more than welcome to work ahead. That's fine. Doesn't bother me one bit. However, make sure that you are keeping one eye up here, checking your work to make sure the problems are correct that you're doing, okay? It does no good to practice the wrong way. So make sure you're checking your answers. And let's take a look at number 1, numbers 1 and 2, okay? The directions say which triangles are similar to triangle ABC. Now, let's first of all, and I'm not sure, hold on one second. Did I not get a picture of triangle B? I didn't, okay. Well, I'll draw that up here in a second. Sorry about that. Let's first of all compare triangle ABC with triangle A right here, okay? Now, 4/3 is 1 1/3. We know that, okay? 8/3 would be 2 2/3, okay? Why are you showing that to us, Mr. Earl? Well, I'm going to show you why. You have to know which sides are the longest sides. Look, we're going to see if this triangle is similar to this triangle, okay? So the smallest side is 4. Put that over the smallest side over here, which is 4/3. Okay? Take the next smallest side, 6. Put that over the next smallest side over here, which would be 2. And then take your longest side, 8, and put it over the longest side over here, which would be 2 2/3 or 8/3, okay? Now, very quickly, 6 over 2 reduces to 3 over 1, okay? Here, we have 4 divided by 4/3. Watch carefully, please. 4 over 4/3, or in other words, 4 divided by 4/3, right? 4 divided by 4/3. So, of course, we put the 4 over 1. we flip this fraction and we multiply. So instead of using 4/3, I'm going to use 3/4. So 4 over 1 times 3 over 4 gives me 12 over 4, which is 3 over 1. So far so good. Now, let's go ahead and do the same thing to this fraction over here. We have 8 divided by 8/3. Or in other words, 8 over 1 times, and then flip this fraction, times 3/8, and you would get 24 over 8, which is 3 over 1. So, yes, triangle A is similar, is similar to triangle ABC because all three sides are proportional. So we just use the side theorem. Now, if you'll look in your books, I forgot to put triangle B up here, but triangle B, if you'll look, my smallest side here is 4, and my smallest side, if you'll look in your book, my smallest side is 3, 4 over 3. My next biggest side is 6. If you'll look in your book at triangle B, my next biggest side, actually, my smallest side was 2. There we go. And now my next biggest, or no, it was 3. Yeah, I have no idea what I'm doing. Alright, smallest side is 3. The next biggest side would be 5. And we can stop right now, guys. There's no need to even put the last fraction up here. 4/3 and 6/5 cannot be reduced, and they're not equal. So if all three fractions are not equal, then we know the triangles are not similar. So triangle B is not similar. Now let's try triangle 3. Smallest side is 4. Smallest side is 2. Next biggest side is 6. Next biggest side is 3. Longest side is 8. And the longest side over here is 4. If you reduce all three of those fractions, you will get 2 over 1, 2 over 1, 2 over 1, or just 2, 2, and 2. So yes, triangle C is similar to triangle ABC. Alright, number 2. Here we go. Let's see here. I think now we can use side angle side. Notice that we have an angle here, congruent to this angle here. So all that we have to do is see if the sides are proportional. So my smaller side is 6, and my smaller side over here is 5. My larger side out of these two is 8, and my larger side over here is 20 over 3. Okay, so here we go. We have 8 divided by 20 over 3, which is really 8 over 1 times 3 over 20, okay? 4 goes into both of these, 2 and 5 times, and look what we get. We get 6/5. We get the same thing. So this fraction here is 6/5, and this fraction here simplified to 6/5. So I have an angle here congruent to an angle here, and the including sides are proportional. So yes, triangle A is similar to triangle ABC. Now, I forgot to put B up here, so let me look in the book at B real quick, and here we go. 6 is my smallest side. If you look at B, my smallest side is 3. And then 8 would go over the next smallest side, which is 4. Alright? And so 6 over 3 reduces to 2 over 1. 8 over 4 reduces to 2 over 1. So if you'll look at letter B in your book, and again, I apologize for not putting it up here, but if you'll look in your book, you'll see we have 2 triangles, or 2 angles that are congruent, the 2 right angles, and then the included sides are proportional. So yes, triangle B is similar to triangle ABC. Alright, let's take a look at letter C, or triangle C, and then we'll move on from there. Alright, here we go. Now, notice I have an angle here congruent to an angle here. So now I just have to check out the sides to see if these sides are proportional to each other. And if they are, then I have similar triangles. Okay, 6 is my smallest side here out of these two. So 6 over my smallest side is 4 equals 8 over my larger side down here, which is 6. Reduce 6 over 4, that's 3 halves. Reduce 8 over 6, that's 4 thirds. These two fractions are not equal. So even though I have congruent angles right here, the including sides, this side here and this side here, and this side here, and this side here, and this side here are not proportional, so no, letter C would not be similar to triangle ABC. Alright, moving on to number 3. Now, in the figure below, they tell you DEF is congruent similar to XYZ. Find XC and YZ. Okay? So here we go. See this XY right here? Here's XY. XY corresponds with DE, okay? So here's DE6, so I put 9 over 6, okay? Now I'm going to find YZ. I'm going to call this X, so I'm going to put equals X over. Now, what side does YZ correspond with? Well, here's YZ. It corresponds with EF. So I'm going to put X with EF, which is 8. Alright, so 6x equals 72. Divide both sides by 6, and x equals 12, okay? So this length right here would be 12. Alright, now, they also want us to find the length of YZ, XC, this length right here, okay? So let's call that Y. And here we go. First of all, I have 9 over 6 again. That ratio is not changed. And then here, I have XC, which is Y, over. Now here's XC right here, so XC corresponds with DF. So DF would be 12. Right here, 12. So 6Y equals 108. Divide both sides by 6, and you would get 18. Y equals 18. So there's the two lengths. This side here would equal 18. Okay, 12 and 18. Alright, moving on to number 4. Very quickly, they want us to simply develop a proof, okay? And this is so ridiculously easy. ABC is an isosceles, right? DEF is an isosceles, right? So, isosceles, right? So it's right, and this side here is congruent to this side here. Then here's a bigger one. Right angle. This side here is congruent to this side here. Alright, here we go. Now, ABC is isosceles, right triangle, DEF is isosceles. Prove that they're similar. Well, guys, it's so easy. Let's use numbers to prove this. Let's say this length right here is 5. And let's say this length right here is 5. They're congruent. Let's say this length here is any number you want, 9. So this length here has to be 9 also. Well, look, 5 over 9 equals 5 over 9. Look, if these two sides here are congruent and these two sides here are congruent, then it's going to be 5 over 9 equals 5 over 9. The two fractions will always be equal. So I would set this proof up by saying AB over ED let's see. Okay, students, I'm back. I was thinking there for a second. I would simply state that AB equals BC, which is true. And then you can divide anything by, you can divide this side by anything as long as you divide the other side by the same thing. So divide AB by ED, I guess. So divide one side by ED, then divide the other side by ED. Then of course ED equals DF, so you can substitute DF right here. Then look what you got, guys. You got AB over ED equals BC over DF. So there it is. Boom. That's how I would do. That's the plan of attack I would use. And then somewhere you'd also have to state that angle B is congruent to angle D. So once you state you have congruent angles, and once you state that these two sides here are proportional to these two sides here, then you can definitely state the two triangles are congruent, okay? Side, angle, side. Let me say it again. If two angles are congruent and their including sides are proportional, then the two triangles are congruent, okay? Alright, lastly, it's hard to read, but you have a book there in front of you. Find the ratios of the lengths of the corresponding sides of triangle ABC to DEF, okay? So ABC has lengths of 4, 6, and 8. And triangle DEF has lengths of 6, 9, and 12. So first of all, they want us to find the ratios, okay? Well, smallest side here with the smallest side over there, the medium, the middle size with the middle size, then the longest side with the longest side, okay? So we did that. If you reduce all these, you get 2/3 equals 2/3 equals 2/3. So we found the ratios of the lengths of the corresponding sides. Are the two triangles similar? Well, yes, of course they are, because you have all three sides are proportional to all three sides. 2/3 equals 2/3 equals 2/3. So yes, by the SSS similarity theorem, when three sides of one triangle are similar to three sides of another triangle. Okay, I hope this video has been a help. If you have any questions, don't hesitate